I've explained how, using two coherent sets of ripples, that it is possible for them to interfere in such a way that at some distance away, if we think of a line along here, we will find that there are certain parts of the line which has big amplitudes in oscillation of the water surface, certain parts that has no oscillation, certain parts that has big oscillation again, and no oscillation, and so on. So as we move along a line, this line for example, we would see big oscillation, no oscillation, big oscillation, no oscillation. This is a feature of a very distinctive feature of waves. It happens because of the nature of these two waves, the nature of waves, and it happens when two waves that are coherent interferes. So if we see this pattern, if we see this kind of a pattern, it must be because that whatever is producing it has to be some kind of a wave. Now, historically, it was an experiment like this that actually showed that light is made up of waves. Now, we can't actually see what is inside a light, right? We can't see light. Light allows us to see things, but we can't actually see light itself. But it's possible to set up a similar experiment like this and show that we actually have this situation where a situation that's very similar to this one that I described for this ripple tank. So let's have a look at that. Now this is an experiment in which I have a screen. Let's see, with two small gaps. Okay, and there is a light source here. There's a light source here giving out light, maybe a torchlight, and the light goes through the two little gaps. Okay, and some distance away is a screen. There's a screen here. And it was found that when light goes through these two gaps and fall on the screen, a certain pattern of light appears on the screen. We would expect that when light, if we don't know any better, we will expect that when the light comes through these two gaps and falls on here, all we would get here is just maybe some light, maybe a stretch of light down here, nothing special, right? Like when you shine a torchlight. But what was actually seen was this. Okay, what was seen was a pattern that looks like this at the screen. A bright and dark series of patterns, right? Bright, dark, bright, dark, bright, dark, bright, dark, and so on. So this was very odd. Why is it that we have such a pattern? Why isn't it just one uniform stretch of light, just a blob of light coming from here? What is it that caused this bright dark series of pattern? And the explanation that was given when this experiment was done about 200 years ago. It was done in about in about 1800 by a British scientist called Thomas Young. And the explanation given was that it is because light behaves as a wave, that light is a wave. Okay, because if you look at this setup, it is the same, or at least very similar to what we saw just now for the Ripple tank. In the Ripple tank, if you remember, we have something that produces waves on one side of these two gaps, and when the wave goes through those two gaps, we have interference on this side. And if I move along a line, if you remember, I will find waves that have points along the line where the waves will interfere constructively and give a big amplitude. And then if I move a bit further on, there'll be a position where there's the waves cancel and have no amplitude, and then I have big amplitude, no amplitude, big amplitude, no amplitude again. So if we think of the intensity of the light, the brightness of the light as being due to the amplitude of the wave, and that when there's no amplitude, that means there's no wave, no energy, then this pattern actually agrees with what we saw in on the Ripple tank when we had two gaps, and when we have the waves from the two gaps interfering some distance away. So because of this, because these patterns agrees with what we saw on the Ripple tank when we had two gaps, we can actually conclude, and that led Thomas Young to conclude that light behaves as a wave. And for the 200 or more years after that, we have accepted this to be a fact. So this setup has a name. This experimental setup, write that down, is called the Young's double-slit experiment. Right, and historically, it is very important because it shows, right? It shows that light is a wave. Now, but as it turns out, 200 years after Young showed that it is a wave, another property of light was discovered called the photoelectric effect, and according to Einstein's explanation of the experimental observation, it turns out that light can also behave like particles. So that will be the story for a much later session.